Welcome back. Let's talk about another big vulnerability in web applications that involves databases and that is called SQL injection. So we already talked about how this works. So you find a user input on a website that communicates with the database. Usually those inputs are something like usernames or passwords or a page where you're searching for some type of a product. Once you input product, the website communicates with the database to see if it has it. Then the database responds back, and all of that is done with the help of SQL language and SQL queries. But as usual, user input might not be well filtered, and we might be able to inject SQL code there and send our own SQL queries to the database. Maybe on that website there are online accounts and their passwords are stored in a database. If we were to find SQL injection on a website like that, we could potentially extract usernames and passwords of all of the accounts through that SQL injection. This is an example of how an SQL query could look like. It is very similar to English language, and what this statement essentially does is it selects some type of element from a table where some condition is fulfilled. And table is just a part of database. Databases are consisted of tables and columns. Now, I will be real right here. If you're encountering SQL injection for the first time or SQL language for the first time, you might find this a little bit hard. However, through practice, this will become easier and easier. Here we can see an example of how a real-world SQL query could look like. Here, books are our table from the database, ID is our condition, and this star sign indicates that we want to extract everything. Usually in programming world, star sign means everything. Great. Now that we know behind the scenes of how an SQL injection works, let's try to perform one on our DVWA page. So let's go right here, log in as usual to our DVWA page. And let's first select the DVWA security to allow and navigate to the SQL injection. Now, you might notice that we also have SQL injection blind, and this is something that we're going to talk about later on. For now, let's just focus on this SQL injection tab. So, what do we have right here? We have something called user ID. And usually, we would input something like a number right here. So, let's give it a try. If I, for example, input number 1, and click on submit, well, it will tell me that the ID of 1 is a user with the first name admin and surname admin, and that user has ID 1. What if we type 2, for example? We click on submit. Well, we got a user with ID 2, his name is Gordon and his last name is Brown. And we can go for each and every number if we want. For example, the ID 5 has first name Bob and last name Smith. But to search for the SQL injection, what we can do is we can type some special characters, and that might throw an error if there is an SQL injection. For example, if I type apostrophe or a single quote and I click on submit, it will throw me this error. It will say you have an error in your SQL syntax. Check the manual that corresponds to your MySQL server version for the right syntax to use near line 1. And this already is an indication that we have SQL injection bug, since it interpreted our apostrophe as a part of SQL syntax. So for now we know that there is an SQL error because we got an SQL error syntax, but before we continue, let's first explain why does this give an error? Why using a single quote gives us an error? Well, let me show you like this. If I open terminal, let's just go and find a program that will allow us to write text. And here we got some text editor under the usual applications. I'm going to open that and I'm going to enlarge it just so we can type something right here. And now that we open this, let's explain why apostrophe gives an error in SQL syntax. Well, as we already mentioned in our slides, usually we will have an SQL syntax or an SQL query that will look something like this. So select and then something from a certain table where some condition is fulfilled. And for our page right here, if I go back, since we have user IDs, first names and last names, it could possibly look something like this. So select name, comma, surname from the table that could be named something like accounts, we don't know that yet, where ID equals, and then the ID number goes between single quotes. So this could possibly be our SQL query that we send to the database, and then the database retrieves the user under the ID 2. But what happens when we type apostrophe is instead of this 2, and instead of it filtering the apostrophe, it just writes it between these two single quotes. And then we get 3 single quotes. The opening single quote, and then our single quote that we injected becomes the closing single quote, and then the third one is the single quote that's hanging. It doesn't belong to anything, therefore the SQL throws an error that it has 1 single quote more than it should have. And whenever that happens, you got an SQL injection bug. And this is also called the error-based SQL injection because it throws us an error. On the other hand, we got the blind SQL injection that doesn't throw an error, so there are some other methods that we must use for that one in order to figure out whether it exists. Now that we know that there is an SQL injection, what we can do is we can type some other statements as well. For example, we can select the ID number 2 and then close the single quote inside of that SQL query, and we can type some logical statements such as, for example, and 1 equals 1. And keep in mind that this right here, if I copy it and write it down, has single quotes between the numbers. And it doesn't have the single quote at the end because inside of our SQL query, we already have a single quote at the end. So this single quote will cover the last part of this one, and this first single quote will cover the first part of these two. So essentially, once added to our SQL query, it would look something like this. Instead of this single quote, we would have this. And you can see this opening and closing single quote fulfills our statement. Let's give it a try and run this. And we'll just get the information about user under the ID 2. And that is because our statement is correct. So we select the user ID 2 and we say do that in case 1 is equal to 1. And 1 is equal to 1, so there are no problems, it just prints the username. But if we were to type the same command, just change 1 equals 2 and click on submit, we wouldn't get any output right here. That is because 1 is not equal to 2, therefore it won't print the user under the ID 2. That could be another sign that there is an SQL injection. Now that we know for sure that there is an SQL injection, we can try some other commands, such as for example this one. So if I go down here and type 2, single quote, and this is just us selecting the ID number 2, and then use a statement called order by 1, and add dash dash, then space and single quote at the end. So let's explain this command. The reason we have this dash dash, space and then single quote is because that is referred to as a comment. This dash dash is a comment, and we must add this at the end of our statement, at the end of our SQL query, because otherwise it would throw us an error. We must have it so we don't get error when running our SQL commands. And order by 1, we'll just check whether there is column 1, and we are going to do that for 2, for 3 as well, and we're going to see how many columns do we have. So if I copy this and go back to here, paste this, click on submit, we'll get an output first name Gordon and surname Brown. That means this is a valid statement. Let's try with order by 2. So just change from 1 to 2 and click on submit. And this is also a valid statement because we get the first name and surname. And if we try number 3 and click on submit, well, there is an error, unknown column 3 in order clause. And that's how we know that we have 2 columns. Now, let's see what those 2 columns are. If I go and type this command, and I'm going to type it right here first, 2 as our ID, and then union select 1 and 2. And let's not forget our comment at the end by specifying dash dash and then single quote. If I copy this and I paste it right here, click on submit. Okay, so we get this output right here. The first name for the ID 2, and we get the first name 1 and surname 2. Now that we know that we have 2 columns and that we have an SQL injection vulnerability, we're going to start extracting data. So we know that we have 2 output fields, the first name and the surname field. So we're going to try to extract the database name and the user of the database. To do that, we can type the command to select the user ID and then union select, and we're going to type database open and close brackets and comma user open close brackets. At the end we add our comment with a single quote, and here we are specifying the functions called database and user. These 2 functions are already defined in MySQL. So let's copy this command just to see the name of the database and the name of the user, and type it right here, and we get the first name, which will store the database name, which is dvwa, and the surname or the user, which is going to be root at localhost. Now that we know this, we can try to extract the list of the databases by injecting the following command. So after this, we once again start with 2 and then union select. These select statements you can also type in capital letters. It doesn't really matter. You can type capital or lowercase letters. What matters is that you type the correct command syntax. So right now we're going to call for schema underscore name, comma 2 from information underscore, and let me just enlarge this so the entire command can fit. So 2 from information underscore schema dot schemata dash dash and then close single quote. Okay, so let's just copy this and see what do we get with this command. If I copy, go to my page and paste it right here, well, we get quite a few results back. And we essentially get different databases outputted right here. We got our DVWA database, we got Metasploit database, MySQL database, owasp 10. And since we're doing this all inside of the DVWA application on our Metasploitable, we would most likely be interested in this DVWA result. So let's try to extract even more from it. We can use the following command, which is id2 and then union select table underscore name, comma 2 from information underscore schema dot tables. So you might be wondering what even are these, and this is just regular syntax for the SQL language. These are just something that you will get used to over time. Once we type from information schema dot tables, where the table underscore schema is going to be equal to the one that we want, and in our case that is dvwa. So we can just type equal open single quote dvwa close single quote and then our comment dash dash quote. Let's copy this entire command, copy it and paste it right here. Now I'm not sure if I copied the entire command, so I'm just going to go back and add what's missing, which is 2 and then single quote and then union. Click on submit. And here is the output. So with this command, we sent a query where we requested names of all the tables inside the DVWA database. We got 2 results, which is guestbook and users. And this users right here could be interesting for us, so let's dive deep into it. We want to extract columns inside of this users table. We can do that by injecting this command right here. So let me just make a few spaces and type the next command, which we, as usual, start with 2 and then apostrophe. Union select, and now we're selecting columns, so we are going to type, instead of table name, we're going to type column underscore name, comma, column underscore type from information underscore schema dot columns. Remember, in the last command we used dot tables. Now we are using dot columns because we are furthermore diving into our database, and we need a condition at the end. So where table underscore schema is going to be equal to dvwa and table underscore name equals users. So remember, we got two results right here, and we want to go with the users one first because that looks more interesting to us than this guestbook table. Okay, so let's copy this command, and now I'm going to copy the entire command. So select, copy, and paste right here, and click on submit. And again, we get a lot of results. Here they are. Can you guess which one out of all of these columns are most interesting to us? If you guess the password one, well, you guessed right. But we also want to extract other columns as well, such as usernames, which we get right here, such as first names, last names, IDs as well, and all of that we want to extract. To do this, we will need to use the concat function, because we only have two fields available to input our result. So we must concat a few results in one field and the rest of the results in the other field. We can concat, for example, user ID, first name and last name in the first name field, and we can concat the usernames and passwords in the surname field. So let's see how that command would look like. If I go back and add a few more spaces, let's type 2 and then apostrophe union select, and then use the concat function to concat multiple fields into one, and we can do that by specifying which fields we want inside of this function. Let's type user underscore ID as a first field, comma, and we're going to separate them with two dots. So comma, and then first underscore name, which is going to be our second field, comma, let's use again two dots to separate that also from the last name. And these are the three fields that we're going to concat into first result. Then after it, we want to type comma and concat the usernames and passwords into second result. So let's type it like this, password. And at the end, we must specify from where are we extracting all of this. And in our case, since our database is called dvwa, we're also accessing the users table. So we must type it like this. So extract all of this from dvwa.users. Add the comment at the end. And let's copy all of this. And submit. Well, here it is. Here is all of the information about all of the users from this database. In the first name field, we get the user ID, followed by the first name, followed by the last name. And in the surname field, we get the username and the password. So we successfully performed SQL injection, and we extracted all of the information about all of the users inside of their database. But you will notice that passwords are rather strange, right? This is because they are hashed. Usually, websites store hashed value of passwords inside their database for security reasons, since even if something like an SQL injection happened, and someone managed to extract the entire database, they wouldn't get passwords in plain text, but rather as hashed value that they need to run a dictionary attack on in order to find it in plain text. And by looking at them, I would say that this is probably MD5 hash. We can figure this out by copying one of these passwords, so let's go with this one for example. Going to Google and just pasting it inside of the search bar. And we can see most of the results are MD5, 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 so we can guess that this is an MD5 hash. And since this is an easy password, if I click on this link, it will even tell me which password this MD5 hash is. So it is the password ABC123. So if I go back to this page, we can conclude that Gordon has a password of ABC 123, because this website showed us what is the string of this hash that we pasted. We can do that for any other hash as well. As long as it is a simple password, it should manage to find it online. If I go and paste this one, for example, go right here, click on this website, MD5 hash for password is this. So it seems that our MD5 hash is a string of password. So our user called admin has a password that is simply just password. And that is how you extract the entire database with the SQL injection vulnerability. Now, this is probably the hardest bug that we are going to cover inside of our web application section. And it might take some time for you to get used to it and to get used to all of this SQL syntax that we performed right here. For example, these database functions, user functions, could be known by someone that already knows SQL, since these are already the inbuilt functions, and that also stands for all of these syntax like table name, like information_schema.columns, and the rest of these commands. But if you practice it more and more, you will eventually get better at performing SQL injection. Okay, great. So we performed SQL injection, and in the next video, we're ready to continue discovering even more bugs on our DVWA application. See you there.